So, I want to talk about change. I normally talk about things that are around change, the consequences of change, the consequences of not change. So I will be talking about that. I often also talk about software architecture, programming languages, language evolution. All of these are actually about change. I also like natural language. So in spite of what Peter just said, English does change every 6 months, except it doesn't have a version number. Yeah. I think it's fairly clear now that if you went back 25 years, a number of the things that we talk about now would be incomprehensible to people. In fact, if you want to put a real mark on it, 30 years, and it turns out that most of the conversations that we have would be utterly incomprehensible to somebody in 1993. Okay? There is actually layers of change. In fact, a very good example of this is that I used to have a very simple representation online, but thanks to the fragmentation of social media, you can find me in a lot of places now. I've just given up putting it in one place. So there we go. Yeah, just Google Kevlin Henney, you will find me. So who has... Okay, we're going to do is, who has heard of Sandman by Neil Gaiman? Who has watched the Netflix show, which is a very good adaptation? And for bonus points, who's actually read the graphic novels? Okay, well done, you are my people. So, this deals, Sandman is a fantasy, and there is in it 7 beings who are known as the Endless, and they represent, they're embodiments of certain aspects of life. One of them is delirium, and she is kind of a bit scatterbrained. She embodies the idea of delirium. And she asks, what's the name for things not being the same always? You know, I'm sure there is one, isn't there? There must be a word for it, the thing that lets you know time is happening. I love that. That's such a lovely way of putting it. How do you know time is happening? And her brother, who is the Sandman, but known as Dream, and is an entity of very few words, says change. Oh, I was afraid of that. And that question of change cuts to the heart of something that we, as human beings, kind of struggle with. So, quoting the great Grace Hopper, she mentioned humans are allergic to change. They love to say, oh, we've always done it this way. Oh, it ain't broke, don't fix it. Oh, that's always worked like that, don't change it. Yeah, it's always been like that until the moment that it isn't. That's why I have a clock on my wall that runs counterclockwise. And Grace Hopper is the reason that I have a clock on my wall that runs counterclockwise. Yes, in this wonderful age, given that I just said going back 30 years, people have no idea what most of our conversations are about. A few years ago, I thought, instead of just quoting Grace Hopper, I live in the age of internet shopping. Surely somebody must have created clocks that go backwards. Oh yeah, more than one or two, it turns out. So, Christmas is coming, you know what to order. And there's a point here. And that point that challenges us is the question of architecture, the question of software architecture. Now, there are many different definitions of software architecture. First definitions that I've come across go back to the 1960s. And because it's a metaphor, it's very difficult to say there's one true definition. People use it with different implications, different consequences. But some definitions are more useful than others. So the one I tend to use is the one from Grady Booch. Architecture represents the significant design decisions that shape the form and the function of a system. Now, there is an interesting question here, is how do we know when a decision is significant? Interesting. We'll find out. Where significant is measured by cost of change. So in other words, he doesn't describe it physically. He doesn't describe it as the large things in terms of the big boxes on your PowerPoint diagram, because that's PowerPoint architecture, and you can make your boxes any size you like. There is no significance. If anybody ever shows you a diagram and says this is the architecture, the one thing you know is it's not the architecture. It is a view of the architecture. But there are other views. And the box size is not an indicator. But the cost of change is. And there are lots of ways of measuring cost. I mean, obviously, cost is one thing. In theory, people track it, but I find that the people who track costs are not the people who develop the code. So there's a disconnect there. It's easier to sometimes measure time. Time is money, I guess. So time is another way of measuring it. So sometimes you say, oh, that's going to take a lot of time. Or put another way, a lot of effort. Sometimes we measure it in terms of effort. When somebody says, can we change this in our application? You need to do the, that's how you know that it's going to be architecture. It's not a small change. When somebody says, it's architecture. Because you're changing something fundamental that everybody depends on. In fact, there's another way of measuring it. It's pain. Okay? And the point here about a lot of these things is we do not know in advance what these things are. Ralph Johnson, one of the gang of, speaking of 30 years ago, one of the original Gang of Four design patterns authors, he made this observation: architecture is the decisions you wish you could get right early in a project. But you are not necessarily more likely to get them right than any other. The point is, you can't predict the future. Architecture is ultimately a story of regret. Okay? You don't know in advance what those things are. But there is a problem. How many people here, I just realized the connection between those two sentences. You'll understand what I'm saying. Right? How many people here use C++? Yeah, okay, right. So, C++ developers are unique in their tolerance of pain. Yeah, you know what I'm talking about, exactly. I've been using C++ since before 30 years ago. But there's also something that C++ programs have a habit of doing: future-proofing their code. Oh my goodness, I wish we could go back and find all those pieces of code that have been future-proofed and hold them up and show them as articles in a museum. Because the problem here is over-design. Of all the people that I ever train and do workshops with and do consultancy with, everybody's prone to over-designing. But C++ programs particularly, it's a little special, there's a cultural thing. That which is over-designed, too highly specific, anticipates outcome. A quote from William Gibson in his book, All Tomorrow's Parties. The anticipation guarantees, if not failure, the absence of grace. In other words, either your aspirations and your future-proofing will fail miserably because you do not know the future, or you'll just end up with a bit of a mess. Oh, C++ programmers, I present you with basic string, which has been in the C++ standard since before the first standard. This is one of the most ridiculously over-designed classes, and yet most of it achieves nothing. Importantly, we don't know it as a class like this. We know it as a template. And that template takes three parameters. One of which is the character type. You know what? That is the one thing that has changed and was well anticipated. We have gone from having simply 1-byte chars to wide characters to UTF-16, 32, etc., etc. 64, 128, 256, who knows? Okay? But what are these other two? Character traits. Oh, that's to allow you to internationalize things. And allocator, that's to allow you to do memory. It doesn't work. Neither of these work for anything. I mean, let's look at character traits. This is just noise. This does not solve a problem. This is designed by people who do not know how to do internationalization. It's not that easy. Or to put it another way, it's actually not that hard. And the allocator stuff, it was over 10 years before anybody actually came out with something that was useful in that space from when it was first introduced. It was about 15 years before somebody was able to make it portable. That is not how you allow people to parameterize memory. It's just guesswork. In this book, published a number of years ago, 97 Things Every Software Architect Should Know, I included an item which I expanded in my blog with a very simple title, and that's all I'm going to quote. Simplicity before generality. Use before reuse. If it's not simple, it's definitely not going to be general. And if you can't use it, where's reuse going to come from? Keep it simple. So let's look at something else here. Let's actually look at some inspiration from actual architects and architecture. This is a book that was published in the 1990s by Stuart Brand. It's a lovely book. Again, Christmas is coming. I'm not on commission. This is the kind of book that if you have it and other people know that you have it, they instantly go, Not just a software developer. Sophisticated, intelligent, cultured, knowledgeable, they will look at you in different eyes. So this is a good coffee table book. It does have beautiful pictures. We start with the cover. You see two buildings there in New Orleans in the mid-19th century and how they've evolved. They were identical, but over 150 years, these two apparently identical things have experienced different owners and different usages. They have diverged. You could not have predicted the future of either of these two from first principles, nor looking at them now would you ever have understood that they share common DNA. This is the surprising thing. A lot of people look at architecture as static and unchanging. No, the story of building architecture is architecture changes. It just changes at a different scale to humans. Architecture changes over the generational scale. Software architecture also changes at a higher speed, but not consistently. There's an observation in this book based on the work of Frank Duffy, the architect Frank Duffy, about different layers of change in a building, particularly office buildings. And Stuart Brand takes this work and identifies 6 layers of change. What is the most stable thing in a building? Well, where it is, the site. Then there is the load-bearing structure, the columns and walls that actually hold the building up. Don't change these too often, please. And then there is the skin, the facade of the building. For an office building, this is over the course of decades. Then there's the services, the lighting, the air conditioning, the heating, all of these things. These change on a roughly 5 to 15-year life cycle, the cabling and all that kind of stuff. It's why in a lot of buildings you will find, particularly office buildings, you will find false ceilings, false floors, and false parts of the wall to allow ease of change rather than ripping out load-bearing structures. Then you have the internal space partitioning and then the stuff, the tables and the chairs. Now, the point here is not that you go back into the office next week and go, oh, I've got a great new idea for our architecture, folks. We're going to have 6 layers and they're all going to begin with the letter S. That is not the lesson here. The lesson is one that was captured in another pattern by Brian Foote and Joe Yoder, shearing layers. The idea that different artifacts, the observation, different artifacts change at different rates. Therefore, factor your system so that artifacts that change at similar rates are together. In other words, you bring the layers of change and stability. If you actually look at many layered systems, whether you're looking at network protocols or framework stacks, you will actually see there's a great deal of truth in this, that when somebody tries to shake something at the bottom, it causes repercussions all the way up. So structure your system not simply by layers of abstraction or technology layers. Use this as another insight. And if you are working on a legacy system, I have good news for you. It's not often anybody ever says that, is there? You know, if you're working on a legacy system, normally people say, oh, I'm so sorry. But no, I have good news for you. It means you have history. You can learn from history. There's this book by Adam Thornhill, Your Code is a Crime Scene. Who's come across this book? Oh, nobody? Well, I would put that in your Christmas list, but there's a 2nd edition in January, so don't get it for Christmas. Okay? There's a 2nd edition in January. And really, this is about using the data from the history of your source code. We're not very good at using our own data. The simple observation that Adam makes. Measuring change frequencies is based on the idea that code that has changed in the past is likely to change again. Okay, it's trends. It's statistical. You're not predicting the future. You're doing this probabilistically based on knowledge that you have. Now, this lovely observation from Rob Smallshare. He wrote a paper nearly 10 years ago looking at the dynamics of Conway's law. Conway's law was mentioned earlier before lunch. In other words, the nature of organizational structure and the effect it has on your architecture. But what Rob was looking at here was to do with change. Now, there's an awful lot more. This is a wonderful paper. It's definitely worth going to read. But I'm just going to lift one observation that he makes. He talks about the half-lives. So half-lives, not mean, the half-lives of various entities in the software space. Yeah, developers, look, if you're on a long-lived project, look around you. Half the people were not there 3 years ago, typically. CEOs actually last quite a while, turns out, which is good news. Windows XP, just under 5 years, yeah. Lines of code. If you wrote something yesterday, there's a 50-50 chance it'll still be running in 2036. Oh, and if you wrote a class yesterday, there's a 50-50 chance that class will still exist in 2060, just to scare you. And if you've written anything more significant, a subsystem, a component, a module, a service, there's a 50-50 chance that in the tail end of this century, it'll still be there. But that XP thing, a lot of people go, oh, but there's not many installations of XP around these days. Half-life is about halving. Yeah, there are. People send me error messages. Well, everything I'm about, this is in the last couple of years. It's geographically independent. Or we could go to Windows 2000. That's still around. This is 5 years ago. But if you want a real scare story, we could go back even further, say 30 years. Yeah? Now, so this is the interesting thing. People send me pictures of failure screens and stuff like that, and I use these sometimes to talk about software architecture. I use these sometimes to talk about change, sometimes to talk about testing, sometimes to talk about the fact that in software development we are the largest creators of installation software or installation art in the whole of history. So let's talk about this idea of change and relative change. Because sometimes people will say, you know what, we've got our code, and it's built on other technology. I'm going to use technology as a catch-all. Your platforms, your choices of operating systems, your tooling. And let me just get you back. Let's go back to that one. And there's the idea that your code is going to change over time. Okay? Then we have the idea that sometimes your technology changes, but your code doesn't. Now, that doesn't mean that your code is bad or anything like that. Intrinsically, it has not changed. Code does not decay or anything like that. It does not rot. But the problem is, let's look at it from another point of view, the one of relative change. If we look at it from the point of view of technology, and we see everything else that was working, and oh, it's not broke, don't change it. Oh, yeah, we're still using C++ 98. I've got somebody who's still doing that. People who are still thinking about migrating to C++ 11. People who aren't even thinking about C++ 20. And it's just like, I'm not telling you should use always the latest version, but I am telling you that you're going to have a problem, because the distance is ultimately what defines things between the front end and the back end. You are forced by playing the game to at least acknowledge that there is a game. Now, when we come to this, unfortunately, so a lot of people look at the technology adoption cycle. And the technology adoption cycle is kind of, you've got a leading edge or bleeding edge of innovators. And then there's more people who adopt it early. And then sometimes, and this is how I first came across this curve, there is sometimes a chasm, a gap, where a number of technologies will fall and fail. And then we get the early majority. Now we're all doing it. And then there's the late majority. And then there's the people that really won't move. But they eventually have to. Now, has anybody come across this curve in any form or other at all? Yeah, so a few of you have. Okay. And it's normally described like this, and I've taken it from a site, that sometimes people talk about it as technology maturity. This is not correct. Interestingly enough, the actual title of this piece is embedded in the URL, technology adoption. This is correct. It's about technology adoption. People often confuse things. This has nothing to do with technology maturing. It's market maturity. It's nothing to do. The technology could actually remain static. It's to do with people. It's nothing to do with the technology at all. This is not actually about intrinsic innovation. This curve, in fact, I downloaded the paper recently, it originally comes from an investigation into the adoption of agricultural practices in the United States of America in the 1950s. It has nothing to do with innovation, breaking things, or anything like that. It's actually just to do with how people adopt ideas. So it's not to do with the technology. It's actually to do with the market. Put another way, it's to do with the people. So let's go back to our code. Some things will change because Not because of our code, but because of the context of our code. Because, in one sense, that's the cost of doing business. You've got to keep up with stuff. Up to a point. Doesn't mean you have to be on the bleeding edge, but you don't want to be in the latter part. Why is that? Why is there an effect there? There is an effect there because of security, because of the ability to employ people, because of what customers actually want to use. But there is also the side where we change the code. And this observation from Meyer Manny Lehman, it dates to 1980. In fact, it actually dates to the 1970s. He made this observation prior to this, but the paper which contains this observation was published in 1980. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. He made this observation without the language that we now use around this. Even the term legacy was not in currency in 1980. Legacy was not used to describe software until 1989. The debt metaphor was not introduced into software until 1992, and it was not adopted widely until this century. But he made an observation here. But what I find interesting is he's talking about a natural consequence. A consequence here. He uses the word maintain. And there is the idea that as you involve yourself in making a change into a piece of code to adopt a feature, you will inevitably disturb the code around it. Your code needs maintenance, but not the way. But this is the funny thing. We've ended up using the term maintenance a little bit incorrectly. Maintenance is something that happens as a result of wear and tear. People these days use the term maintenance to talk about fixing bugs. That's not maintenance. That's called fixing bugs. That's not a thing that happened That's not a thing that happened because you use the software, or it's not a side effect of the software's involvement with the world. It's always been broken. If you've got a bug, it's always been there. It's just been discovered. Maintenance is about the consequences of interacting with something. In this case, you change, you add a feature, you perform an optimization, and you disturb what is already there. And even if you think you're making the best change, trust me, you need to look at it from a bigger context, because the whole point is to do with focus. If I go and I cook a meal, so I'm cooking a meal tomorrow night for my wife and son, because they're getting in later. So I'm going to be getting back before them, and so I'm going to cook a meal. That is my goal, is to cook a meal. I'm also going to make a mess. That is not my goal. That's a natural consequence of the way the universe works. In order to create a meal, I will also create a set of dirty dishes. That is part of what it is. When you make a change to add a feature to your code, you will make a mess. No matter how good you are, you will make a mess. And you will make a mess because you are, one, because of the universe, and two, because you are human. You will be focused on the change you are making. And focus, what is the definition of focus? The definition of focus is you're ignoring everything else. By definition, you are not focusing on everything else. I don't care how good you are, you're going to make a mess. Okay? Kate talked about good this morning. The difference in the kinds of good is what you do about the mess and how much mess you make. The question is not, are you going to make a mess? You will make a mess. And sometimes it takes you a few months to discover that. Sometimes you leave the company before you realize that. Sometimes you leave the company because of that. The point here is the cost of doing business is you maintain your code. You maintain its complexity. Otherwise, what happens? It gets messy. Well, these days we tend to use other vocabulary when we talk about this activity. But for some bizarre reason, businesses that apparently run with financial concerns don't pay attention to this. And so they end up with effort. I'm using effort rather than cost, but translate it to cost if you want to sell it to your business. Over time, unless you do something about this, your costs, the cost of actually trying to change your code and actually do stuff with it will increase over time. Now, sometimes people talk about this idea, well, we'll just refactor, we'll simplify. And this is good. This is significantly better. Even better, do it continuously. The point there is, if your business is not accounting for the fact that refactoring or maintenance is part of software development, not some kind of optional extra, I keep hearing this from developers say, oh, but we've been told to prioritize features. Yes, I have news for you. And you need to pass this on to your organizations. Features are made of software. And software is made of code. It's not made of magic. It's not made of spreadsheets. It's made of real stuff that people work on. If you want to work on features, your code had better be good. Otherwise, you are wasting the company's money. And companies that do not prioritize this are wasting their own money. So people often try and use the metaphor of technical debt. I think technical debt's a really good metaphor, but people are misusing it. People have misunderstood its implications. People often say, oh, yeah, we've got a terrible problem. What's your problem? We have technical debt. Okay, what's your problem? Kevlin, we just told you. No, you just told me you had debt. Debt is not intrinsically good or bad. The question is, do you know what your debt is, and are you managing it? Yeah, my wife and I had a debt. It's called a mortgage. I love the fact that the word mortgage begins with the French word for death. It tells you everything you need to know. So the point there is we had a mortgage for decades. It was managed. We understood exactly what the terms and conditions were, and we had total control over it. I mean, obviously, nice to not have it, but it was not intrinsically a problem. If you say you have debt, you haven't told me the problem. If you say we have no idea what we're doing, now you've told me the problem. If we have unmanaged debt, and my God, we're just running up the meter, that's your problem. If we don't know what debt we have, that's your problem. It's the management of your debt, not the presence of your debt, that is the issue. And more importantly, this is also not magic. It doesn't just appear. It comes from somewhere. And this is one of the things I recognized recently. The real problem that people are failing to notice is the problem of technical neglect. Technical debt is an effect. It's a consequence. Unmanaged technical neglect is a consequence of something. What is the cause of that something? And this is why it's hard to see. Technical neglect is a thing that does not happen. It's very hard to see a thing that doesn't happen. It's really easy to see an action. When you make a change, I can point to the change. When you don't make a change, I can't point to the absence of change. It's almost invisible. But this is what adds up over time and gives you unmanaged technical debt and ultimately prevents you from changing. If you have unmanaged technical debt, we heard about security being a primary concern in the session before, in the roadmap. I love the fact that security means you have to know what you've got. You can't just have dependencies and not know what they are. If we say, oh yeah, we care about security. Oh, so tell me about your dependency structure. Honestly, we have no idea. You've told me that you don't know what your architecture is composed of. You don't know who or what you depend on and how it might change. Maybe there's Windows XP in there. Somewhere down there in the lower layers. That's part of your system. So the idea is you have to have a full accounting and a full appreciation of what it is that you hold. And so the idea is that we have to pay a little more attention. What are the things that we're not doing? Sometimes we don't refactor before change. If you're going back to the kitchen, cooking in a messy kitchen is a lot harder than cooking in an already clean kitchen. If you're going to paint a room, it helps to move the furniture out the way. That's not extra work. That's part of painting the room. Yeah? Oh, I'll just paint round this. Or you could move it. I'll tell you what, I'm going to move it. That's the first thing you watch anybody who's a professional decorator. They prepare the space. Have you prepared the space? I don't care if it's a small function or a large class. Have you prepared the space? Is it ready for the thing you're going to do, or are you just going to make life hard for yourself? Yeah, I'll just paint around this bit. Okay? And then not refactoring after the change. Because, however good your focus is, it's still focus. Now focus on the things you weren't focusing on. Have I broken an assumption? It's not to do with creating mess in the sense of duplicate or bad code, but it's sometimes something no longer fits, or there's an assumption that's changed somewhere else about how this piece of code is being used. In fact, the best one is, oh, look, we don't need this anymore. This piece of code is now dead. That's really nice. You can go home safe in the knowledge that you've deleted some code. That's a nice feeling. Not testing. It turns out that this turns out to be quite an important thing. Yeah, it's one of the things I really like about certain kind of cultures. Open source culture is quite big on testing. Because it turns out that other people don't really want to use random stuff they pick up off the internet if they don't know that it's got kind of support and culture around it and an active community and a proven track record. Tests. Avoid breaking other people's assumptions as well as your own. Reviewing code. Get another pair of eyes. Of course you're great, but you're not perfect. Somebody else's eyes will see something that you cannot see, simply because they belong to somebody else. Make a note of those decisions. You don't know which are going to become the significant ones. They multiply over future. But try and keep some way. Architecture decision records, if you're not familiar with ADRs, go and Google that. Architecture decision records, but just something really simple, an idea of like just tracking that so that you have that idea that seemed obvious to you and clear in your mind today. In 6 months' time, you'll be scratching your head over. Yeah? And when you leave, everybody else will be scratching their head over. Make sure that you socialize your decisions, but record them. I'm not talking about writing large Word documents and hiding things in the vault of SharePoint never to be found again, the classic write-only repository. But just record your assumptions so you know you are not going to remember everything that is so obvious to you today because you change. But also revisit those things. Just because it was a good decision last year does not mean it was a great decision this year. Yeah? Context changes around you. So the idea is your decisions that you take today change because of other assumptions. So it's not to invalidate past decisions, but it is to acknowledge that, yeah, it was good last year, 5 years ago, 10 years ago, but there's no reason it's going to be that. There's no guarantee that the decisions that are good this year are going to be good next year. And then not updating technology. You've got to track this stuff. If you're in technology, it doesn't mean you have to be at the bleeding edge, but it does mean that you need to be somewhere in the center, because otherwise you're going to find it hard to guarantee that you have security updates, Windows XP, guarantee that you actually have people who want to work on this. You want to draw from a large population. You want to draw from a base of knowledge. You want to be able to go online and know that somebody on Stack Overflow actually has the answer, or that ChatGPT has actually been trained on data that is real, as opposed to making stuff up, which has been my experience so far of ChatGPT. It's very good at making stuff up, even in technologies that it's never worked with. So, there is this idea. We come out the other side. We might start with fear, but I think you need to come out of this realizing, this is totally normal, and always has been. According to the philosopher king, Marcus Aurelius. We've known this for millennia. The universe has changed. Life is what thinking makes of it. Thank you very much.